Hello, ladies and gentlemen. Okay, so as promised, I'm going to have to look at this example that we did, number 2, and take a look at the restrictions on that we were doing there. I kind of dropped the ball when I was teaching that to you today, and would like to come back and sort of fix this up. So a couple of things here. First thing I'm noticing when I'm looking at it is that it looks like I went after the restrictions on H, which is kind of interesting. Here's H, and I get that, but I went for the restrictions on the wrong variable, because what I have my function in terms of, once I do the substitution, is X. So that's the value I'm going to get for my critical value moving on. I'm going to get an X equals something, and so it's X that I'm going to need the restrictions on, not H. It is true that H needs to be greater than 0, and I'm going to use that. I'm going to use that in just a little bit, but right now I should be focusing on the restrictions of X and not H. So this is going to have to change. So I've set myself up down here, and let's take a look at what we have. So this is all the pertinent information that we have from the question up above, and so I'm going to go after restrictions, and I want restrictions on the X, okay, because that's the one that I've solved for, so that's the one that we want restrictions for. Make that a little bit bigger here. Okay, so I want restrictions on X. Well, first of all, I think it makes perfect sense to everyone that X is going to have to be greater than 0. And we can say at the same time that H must be greater than 0. There must be a value for this length, and this length, otherwise there's no box. So we know that X must be greater than 0 and H must be greater than 0. This is our lower bound for X. Okay, this is the lowest it can be. That's our lowest bound for X. What we need now is an upper bound. Is there a highest value of X that it can be? And it turns out that I think there is. I think there's going to be a highest value, and it's going to come from understanding H also needs to be greater than 0. So I'm going to use our isolated value for H, which says that H is equal to, let's see, I'm going to use it here. H is equal to 108 minus x squared over 4x. And I'm going to use that in conjunction with the idea that H must be greater than 0. So that means that if that's got to be greater than 0, then this has to be greater than 0, okay? Which means that 108 minus x squared over 4x must be greater than 0. Now looking at this, the 4x on the bottom, when I'm talking about things being greater than 0, I'm really talking about their sign. There's 4 possibilities for this, and the 4 possibilities are either I'm going to get a positive over a positive, in which case I'm greater than 0. I'm going to get a negative over a negative, in which case I'm greater than 0. I'm going to get a positive over negative, in which case I'm less than 0. And I'm going to get a negative over a positive, in which case I'm less than 0. So these are the possibilities that's going to happen. It's really only the sign that I'm interested at the moment. So if I get rid of this, because I want that space to work, and if we examine the bottom, 4x, well, we know that x must be greater than 0. That's the lowest bound. So I can't be putting in a negative in here. So this is always going to be positive. So that's always going to be positive. So that leaves only the top to change signs. So that means that 108 minus x squared therefore must be greater than 0. Well, if I'm going to work with this and I'm going to rearrange it, I'm going to take the x squared to the other side. It's 108 is going to be greater than x squared, which means that plus or minus 108 is got to be greater than or equal to x. Now, again, x has got to be greater than 0. X has got to be greater than 0. So there's no way that I can have x being less than negative 108. So we're going to omit that. That's absolutely cannot happen because, as we've said, x has got to be greater than 0, and that is not greater than 0, which leaves us that x must be less than square root of 108. Now, I think it was Luca in class that got upset when I took 108 and square rooted it, and I estimated it as approximately being 10.4. But hey, we're okay. We're going to estimate that at approximately 10.4, or we can leave it as root 108. And you know what? He's right. He's right. That is exact, and mine is an estimate. So what we know is, so far, is that x needs to be greater than 0, but it's going to have to be less than the square root of 108. And that took a lot of work. That took a lot of thinking. There's a bunch of stuff in there. You should be able to work through it, and we'll do more tomorrow. So bottom line, the restrictions were that x has to be greater than 0, and that h must be greater than 0. And we worked through all that, and for h to be greater than 0, that means that x must be less than 108. So x is less than square root of 108, sorry. And that's what we get. Those are your restrictions on the variable. So as long as the answer that we got is within that range, we're good to go. Going back up and looking at that question again, I think we came up with a h value of, an x value of 6. And that is certainly well within our restrictions of 0 and square root of 108, which again, remember, is approximately 10.4. So we are good to go with that critical value being on our restricted domain. What's the only other thing I might add to this? There is another way to kind of do this, and that's to look at this part. Let's see if I can grab this. To look at this, and to sort of think about it. And this is what I was trying to show you in class today. So rather than doing all that really good math that I did, you could think about this and you could say, okay, this has got to be greater than 0. Sorry. And you know that x is greater than 0. But is there a largest x that can come in? And when you look at this, there definitely is. If I get x to be too big, then that's going to give me a negative on top, and I'm not going to be greater than 0. So that's how I know that I had a little bit more algebra to do, and that there was definitely an upper bound here. Okay, ladies and gentlemen, we'll leave that, and we'll talk more tomorrow.